Okay, we're going to talk about Yang here, describe the high-level principles and benefits of a data modeling language such as Yang. Um, the benefits of Yang, remember that this is a standard which is defined in an RFC. It is human readable, it provides uniform language, and you must be clear that this is not a programming language. You cannot compile it. It is not a script. It is not an scripting language. You cannot create an application and run that application. It is only a language that will describe how to interact with a device. How can you read information from that device? What information is available for you to change within that device? How that device is going to notify you of any event. So probably if you have worked with IT in the last decades, you might have heard about other modeling languages such as UML. I am not sure if this is used anymore, but there are other modeling languages, so this is not a programming language. So if you use Yang with other tools such as netconf or resconf or any automation tool, you can configure, monitor, and interact with devices. The Yang model uses a tree structure and is based on modules. So this is interesting because the first thought I had when I started reading about Yang is that if I wanted to work with a device, a network device, I will need a single Yang file to know how to work with it. But that is not what happens in real life. What you will have actually, you will be actually working with several Yang files or modules. So network devices have several modules. Yang makes a strict distinction between configuration data and state information. For instance, talking about network devices, the CPU, the current CPU usage is state information. You don't want to change that. You want to know that. So the CPU usage will be a read-only variable. So that will be a state information. Whereas configuration data will be like the IP address in an interface or the message of the day in your router. You want to change that. So that will be configuration data. Yang also supports the definition of remote procedure calls. Remember that you will define how the call will be made into your device and what parameters it will need and what kind of information your device will be sent back as a response. Remember that this is not a programming language, so you will not be actually coding the call. You will only be modeling how the call is made and how the call will be responded. You can also define notifications. If you go and read a Yang file, you will see that it is made of statements. Each statement is usually finished with a semicolon, and the statement is made of a keyword and a string-based naming for that variable. And you can also see braces where you can hold several substatements together. And if you want to create comments, you can use this double slash or this, just like C++. But remember that this Yang language is not a programming language. It is a modeling language. It is very close to C++ syntax only. But I'm talking about the syntax. Oh, by the way, Yang means yet another new generation. So if you want to define or use data types, you have this available for you by default. So for instance, if you want to define a port number, you might want to use a 16-bit wide integer because port numbers are 16-bit wide. But if you want to define an IP address, you can see that there is no IP address here, so you have to create your own custom data type, and you will have to use the keyword, the Yang keyword type def in order to do that. So this is a basic example of a basic model. And the first thing you will see in a Yang file, we will see this, a model, the name of the model. You will see a lot of descriptions. You can add descriptions for anything you write down in a Yang file. You can have a model description, a type def description, a leaf description, a container description, and so on. You will see a lot of descriptions. And this is what we were talking about the Yang. This config true and config false is what defines what type of data you're working with. So this will be read-only data, probably used for state information. So most probably the read-only data will be for state information, and the read and write data will be for configuration. Within the device. So remember that you can have one model or several models. Remember that devices, as I just told you, will use several Yang models, not only one big one, but several Yang. Many of these Yang models are known as deviation, because what is established in these Yang files are exceptions to the rule that is defined in the big or main Yang model. So probably this version of this router cannot do certain multicast that are defined in the main Yang model. So this particular device will have a deviation Yang file that establishes that it cannot do certain things. So a model will have a header statements, revision statements, and definition statements. The definition statements are what actually will be creating your tree. You can have containers, lists, and leaves. Think of containers as folders in an operating system or a file system, I'm sorry. And you can organize your Yang model using this type of folders that are known as containers. And think of list as tables. So for instance, you can use a list to define an interface. So think of the interface as a table within a database. And what can you have within an interface? You can have an IP address, you can have a description, or you can define the MTU. So this is what lists do, define, and these sort of tables, so you can instantiate them with data. You can also have leaves, which is the simple data, one value, childless nodes. So in this example, the IP address will be a leaf, and the description will be a leaf, and the MTU will be a leaf. And this is an actual example of Yang file. This is the model name, and these are the header statements, the revision statements that can usually be a lot. You can also will see a lot of imports and includes. I have omitted them here for clarity, and you can see also the actual statements that create the Yang tree. You can use the tool Piang that will give you a tree rendering of your Yang file, so you can read it more easily. The actual Yang file can be very friendly, but if you want an even more friendly way to read it, you can use Piang. Notice that there are several marks here. If you see a question mark, that means that this value may or may not exist in your device. And if you see an exclamation mark, that means that this is a boolean that can be either true or false. And if you see a star, that means that this variable is actually a list. So now that you are more familiarized, you have got more familiarized with Yang, you can use netconf. Remember that in order to use netconf, you will need XML. You will need to know XML with a reasonable level of experience. So you will have to create a RPC call, then establish that you want to do an edit configuration. Remember to use your namespace and your message ID with your RPCs. Then you have to establish what is your target. In this case, the running configuration. Remember that netconf uses data stores. You can have the candidate data stores, the running data store, the saved data store, and so on. So in this case, we're going to configure the running configuration. And then we're going to map this path within Yang. We'll have to map this path within XML. So we'll have to create a line for this container, the system, then another line for the next container, the services container, and then another line for the secure shell container. And finally, find the leaf variable so we can change it. So this is how you change a leaf, but how if you want to add an entry to a list. Remember that lists are as tables for a database. So in this case, this will be a table that will be named user, making an analogy that has 3 fields: the name field, the type field, and the full name field. So using XML, you can create a new entry in the table using or establishing the name, the type, and the full name. Remember that you will have to establish the path where this system corresponds to this container, and all the other details we talked about previously. Establish the data store and the RPC with the message ID and the naming space. If you want to use netconf, remember to map your URL, because remember that netconf, in this case, oh, this is wrong. This is resconf. So you want to work with resconf. And remember that resconf works with HTTPS. So you will need an URL in order to interact with your device. In order to build that URL, you will have to map the module name within the URL. Remember that this is this, then colon and the first container, and then map all your way down until you find a leaf at the end of your URL. So you can use JSON or XML as the body when interacting with RESTCOM and your device. There are other keywords that we didn't talk about, but you can look them up if you want to know more about Yang. So if you want to investigate more about Yang, you can look this up. And if you want to actually download the Yang files for your devices, you can go into GitHub. You can go into GitHub, and in this GitHub link, you can actually download the Yang files for Nexus, for your XE devices. For instance, if you have a CSR, most probably you'll have to go here, and For instance, Nexus, you have this YANG file, and remember those deviation files. There are actually several YANG files for the same operating system. That's it.